another topic. That topic being sources of waste that are not in the atmosphere or in the oceans moving around. This is also a problem of scale. It is a problem that you can find individual stories, individual feel-good incidents like this one, where a marine mammal has been tangled in a net. This net is debris from our fishing industry, and hundreds of kilometers of net every year are lost at sea, where they represent a floating example of hazardous waste. So this particular story was one where several scuba divers saw this seal having trouble breathing because the net is dragging it down. They're trying to free it from confinement. Any marine mammal has to go to the surface to breathe, and therefore anything that prevents that is going to kill the marine mammal. We have problems with this with our fishing industry, where our huge trawling nets will capture fish which are perfectly fine. We catch them underwater, but fish breathe underwater. But dolphins and seals caught in these nets are held underwater by the trawling and killed. So we do see these feel-good stories. The idea behind all of this solid, toxic, and hazardous waste is our economic model, the things that we want. Sometimes it's the direct product, like a computer. Well, a computer has a lot of heavy metals, rare earth metals, which are toxic in very, very low levels of contamination in the environment. But this also includes things that are very simple. For example, we have gone the route of individual packaging. We have gone the route of dramatic marketing presented on every package. So high contrast and high color dyes printed on the package so that it catches your attention and you will buy it. We have gone the route of disposable items. So wherever possible, we simply make it out of a cheap material and use it once and throw it away. So these decisions have led to a tremendous amount of hazardous, toxic, and solid waste. What do we do with the waste? Well, this is a modern problem because, you know, you look back to when there were 150,000 people in the United States and waste was not a problem. Waste dumps were unsightly, but basically you could place them somewhere where people didn't have to look at them. And if people didn't like the waste dump, they could always go somewhere else and find pristine land. As the population increases, we run out of space. As we try to build waste storage facilities, the universal reaction has been, not in my backyard, do it somewhere else. We need to look at how we can decrease the waste stream first. Recycling is a good news story, but we'll see in a minute the proportion of gain we get from recycling. It just doesn't approach the scale we need to reach a kind of a steady state. We're going to be invoking federal legislation and state regulations, and these acts that are listed here are major among our current legislation to control that, and also discuss what are some management options and some ideas. We're looking for ideas right now. Now, this particular pair of graphs shows us from a standpoint of maybe 1955, 1960 are the first data points. And the red line is showing you the total hazardous waste in millions of tons, going from 88 in 1960 88 million tons. Look how rapidly it's growing, up to 250. Now, it's been level for perhaps the last 15 years. And that's good news that it's leveled off at 250, but that's 3 times where we started. Now, population growth can only account for a certain amount of that increase. The rest of it is accounted for by changes in our behavior, a commitment to individual packaging, a commitment to smaller portion sizes or smaller products. So whereas before you might buy a 5-pound bag of beans, you now have individual cooked portions, and the packaging from that in the freezer compartment contributes to this increase. Now over here we have the per capita generation. This is in pounds per day, starting at 2.5 pounds a day and going up to the mid-4s and leveling off. It's been level now for about 30 years. So that looks like a good trend until you look at this total. With population increase, we still have much more solid waste being generated today than we did when we started keeping numbers. When we look at recycling, how much of this is recycling going to solve? We do see that the per capita generation, the percent recycled, has gone up dramatically per person, 6 pounds per day, 6 pounds per person per day, to 34. That's a great increase. And the total recycling in millions of tons from 6 up to 85. So recycling has made a significant impact. However, let's just do a simple thing. Here's 6 tons taken from 88 tons. That's 82 tons, million tons, sorry, of hazardous, toxic, and recyclable waste. 82 tons. Today, take 85 from 250. What is that? 165. So we have doubled the millions of tons per year in these 3 categories of solid waste. Where do they come from? Paper and cardboard, still a primary product. Paper production threatens our forests and other fiber sources. It also is a recyclable material. 28% of our waste is paper. Now, it's interesting that some of that paper has been treated with bright dyes, with reflective dyes, with toxic dyes. It has been put on, it has been combined with things like foil coatings so that it cannot be recycled. Yard trimmings and food are both organic, and they would be candidates for composting here. These are completely recyclable, and those are the second and third most largest proportions. So what do we do with these? When we get them, most of the things go straight into the landfill. Out of sight, out of mind. Put it on the ground and bury it with dirt. Now, this actually works very well. We have dirt mounds all over our landscape, but we can plant the upper parts with plants, and they don't look too ugly as we drive by. However, we have a volume problem. Given the number of millions of tons of this solid waste, toxic waste, hazardous waste that's being generated, we have to worry about how high that mound can get, how much dirt we have to use to cover it, the expense of dealing with it in this way. It actually is a lot cheaper and a lot faster just to load it into a truck or load it into a barge and drive it somewhere and dump it on the ground. So these traditions that we have are only going to have a limited application in our future treatment of these kinds of wastes. We began with the idea of open dumps. Now, I'm old enough to remember open dumps and open dumping in cities. And their waste was put in open dumps, and you would go out with your rifle and you would shoot cans at the dump. These dumps were known for having active populations of rats and mice and other vermin. They were typically considered very unsanitary and were sources of disease. At this time, being a refuse collector was a much more dangerous job, something that in the scale of things, OSHA, which sets our rules for work and work safety, had not caught up with the need to stand up for these workers. This is still the main method of dumping in what we call developing or third world countries. Now, it's illegal in most economically advantaged countries, but there are some items that are just dramatic in terms of contamination. So, for example, the oil that lubricates our cars, 200 million liters are being poured into sewers. People who change their own oil in the city often pour them down the sewer. Well, the sewer is a direct link in Missouri to the rivers and streams, in coastal areas to the Chesapeake Bay. Or they dump it right on the ground, figuring, well, it will just stay there. It does not. It moves with toxic effect through the ground. This is, each year, is 5 times the volume of the Exxon Valdez oil spill, which was considered a catastrophe because it had occurred just in one place. 20 million tons of plastic debris are dumped in the sea, and they have a dramatic effect on wildlife. This is the trash that washes up on beaches, and even traveling great distance and appearing in places far away from any dumping site. So the stories of, for example, medical syringes that are plastic and washing up on the beaches of Long Island. Stories of the tremendous plastic and refuse raft that is collecting in various places in the great oceans of the world. In the North Pacific, the estimate of loss for the northern fur seal, to just give you an example, 50,000 animals are killed, as you saw in that leading slide, by being entangled in these fishing nets. This says 1,000 kilometers are lost each year. They drown if they are held down, or they starve to death from some kind of constriction of their throat and the inability to catch food and eat. Here's an example of a chick of a bird called an albatross. Albatross are remarkable birds, soaring birds that go out to sea and land and catch fish. But they basically tend to pick up and eat anything that they see. Here you see this albatross chick had debris. I can see a cigarette lighter here. This looks like a plastic tube. I don't know what that is. Is that a cigar holder of some sort? Anyway, eating everything that is of a certain size and accumulating in its gut because digestion can't handle it. Some of our methods are just, let's just avoid it. What we'll do is we'll pay another country to take our wastes, and then it's their problems. So shipping waste to other countries are saying, we want the dollars. Sure, we'll take your waste. In some cases, they are able to set up a small waste reclamation or recycling business. It is not economically viable to do that in the United States, but where you have a country with so many people who earn something like $25 a month, the opportunity to reclaim some of these very low level but very expensive rare earth metals is one they will take advantage of. So here, this reclamation effort. So this is recycling, and what you see here is a cathode ray tube from a monitor, and it looks like an old tube, not a digital one, but it contains metals through here that are worth pennies or more. And you can see the Chinese woman here just basically busting it apart to get to those points that can be sold. We basically see this kind of economic interchange between developed countries and developing countries. What can we pay you to do that we don't want to do it? But what can we pay you to do that gets rid of a couple of problems at one time? You can see the electronic waste. So your obsolete computers, obsolete phones, obsolete monitors, all of this stuff, the keyboards, the mouse, everything that's now been surpassed by that rapid advance in technology is undergoing this kind of reclamation, typically in another country. And then the huge amounts of plastic and glass and other metals are simply thrown into open dumps. This is a problem we don't see, but it is a problem that will come back and haunt us. Sanitary landfills were the great idea of the 1950s and 60s. Look, we can't have open dumps anymore. What we need to do is place the waste on the ground and then cover it with dirt. And that dirt cap keeps it out of sight and out of mind. They were first hailed as a great idea and ran pretty well without regulation until science kind of caught up with them. I worked for the Kansas Geological Survey for a period of about 5 years as a chemist, and my job was to analyze groundwater. And one of my jobs was to analyze water that we took from 5 wells that were drilled in the river bottom land that surrounded the Lawrence, Kansas landfill. So to look at water quality to see if the filtering of the surface soil and substrate was effective in immobilizing toxic wastes, hazardous waste, or were they moving through the groundwater, consequently into these wells, as a sign that the landfill was not doing its job. We had very mixed results on that, even though the landfill was essentially brand new. A problem, we have a huge volume of waste, and the dirt itself, to have a sanitary landfill, takes up about 20% of the space. Sanitary landfill is a great idea until you look at the volume of our trash. There's just not enough space. And given the growing awareness of a landfill and the objections people have with it, this can only be a part of our solution. We now do have guidelines. In the 1990s, laws were passed saying that hazardous substances have to be dealt with in a different way. So typically a clay layer will be laid down at the bottom of an excavation to immobilize, basically prevent water flow through porous layers. Drainage systems have to be in place. Sometimes a landfill will have to be capped with an impermeable or a limited permeability of clay so that water will run off and not through the waste and mobilize these dangerous substances. So here we see a sanitary landfill in its operation. In this case, this one is covered. You can see with a multiple layer sheet. This looks like a rubber sheet here and covered with something that looks more like a fabric or canvas in order to divert water from the underground waste that has been stored here and prevent the movement of hazardous materials. It's inexpensive typically. In its beginning, it was a great idea, but we're getting into some problems with the economics of it, land prices, shipping fees. So typically now, instead of an open dump right outside of town, you might be taking it 50 or 100 miles in order to deposit your trash. Once it is, quote, full, and that's an engineering decision, and impregnated with or pierced with pipes that are releasing the methane that is produced, they then represent a permanent part of the landscape. The comparative cost here, I think, is telling that in 30 years, a ton of solid waste in Philadelphia, the cost of disposal went up 5 times. Now, $100 per ton is still not a prohibitive amount, but this factor of 5 times the cost is one that should be alarming. We can look back to an old method. Incineration was generally out of favor for decades because of its effect on releasing carbon into the atmosphere. Burning it made it disappear. And an important thing about burning is burning reduces the volume. So the amount of waste, if you've ever, when I was a boy in the 1950s, one of my jobs when I came home from school was to burn the trash. Everybody had a refuse barrel kind of out in their backyard or their side lot. And you carried all that burnable trash, all the dry trash out, threw it in the barrel, filled it up halfway, and burned it. And it reduced it to a very, very small amount of ash. And ash accumulated in the barrel and had to be basically dug out and buried every couple of years. So we are now looking at this idea that incineration does produce heat, which can be captured and converted in ways into energy. So now we're basically calling this energy recovery. We'll continue to look at the waste disposal and the atmospheric problems. But the idea of, we're selling the idea that we're making energy, that the heat is used to make steam, and steam can heat buildings or generate electricity. There's 1,000 waste plants internationally that reduce their garbage this way. Refuse-derived fuel, we're doing sorting, the same curbside recycling that we do, where the transporting agency will sort your refuse into different categories of recycling. This does have a higher energy content if it's sorted properly, but again, the human aspect makes it expensive. Mass burn is an idea that we're going to burn everything, and that means a different kind of combustion chamber, one that is supplemented typically with some fuel, but a problem for this. The energy that's generated is beneficial, but air pollution is something that you have to be concerned with. It also reduces the volume of the trash by a factor of 5 to 10. Usually, though, that ash retains the heavy metals and components that are toxic. So even though the volume is reduced, its danger to biological life is significant. So we have here a typical mass burn figure with the truck dumping or tipping into this refuse bunker, then basically filling the hopper with burnable materials and burning it. You can see heat sources here, which are raising the temperature sufficiently that you can boil water, and that steam can be used for generating electricity. But I think what's being mainly drawn here is the flow of waste materials. Electrostatic precipitator means you're putting electricity into it to pull some of that solid waste out. Basically, filters will take out particulates. And finally, you will release a gas. And this kind of arrangement, a stack, allows for particulates to settle. It allows for chemical reaction so that what's coming out the top is much cleaner than what goes into the bottom. Incinerators are expensive to make. Hauling and tipping contain the multiple problems of time and money, so that's machines and labor, but it also includes the fuel that's necessary to move the trucks, which is a factor in our atmospheric pollution. There are levels of, as we look at this more and more, we find particular toxins that are accumulating in alarming levels. Dioxins is something that we in Missouri are aware of because dioxins were a major contaminant in the evacuation of the city of Times Beach, Missouri. Lead and cadmium, the lead in the water, lead in the air, lead in paint, all are problems. Cadmium is one that is present in very, very tiny amounts, but is very toxic in those tiny amounts. We can control this by better sorting. Batteries are a wonderful convenience item for those things that we use that use cells, electrochemical cells, but disposing of that chemical reaction is a very big problem. Recycling. You grew up with recycling, but there are a couple of things about recycling to notice. As I think probably if you ever did recycling and went to the recycling plant to sell, one of the things you definitely did was sort out aluminum cans because you could get money for aluminum. Well, still only about half of those aluminum cans are recycled, and aluminum is taken from a B horizon stratum called bauxite, and it is refined with very high input of energy like electricity. We are subsidizing aluminum production from hydroelectric dams largely, but still only about half the aluminum cans are captured and recycled. Old tires can be placed into asphalt mixtures and incorporated into road surfaces. Now, we are finding ways that these old, basically rubber products can be incorporated. Newspapers can generate insulation, and copper has become limited and so expensive that a major problem in theft in home regions is the copper pipes and copper gutters are being stripped out of unoccupied homes. And for the first time, wires, since electric wires are for major transmission lines are copper, even those wires are being stolen. This is an interesting comment. You know, the best conductor is not copper, it's silver. But silver was relatively expensive, and so copper was adopted as a secondary choice. Excellent conductor for our electrical wires. Also, it ages very beautifully, forming a kind of a green patina that people like. So bronze statues, because of the copper, turn green. And they make excellent gutters. They make excellent pipes. But the price has gone up so dramatically that now it's even It's even feasible or lucrative to steal copper wires and reprocess them. Benefits of recycling are things that you've heard from your earliest days. So it saves money. All those things involved with economy, with efficiency, all those good words, good moral behavior. And in fact, that will take you a certain distance. My wife had a course in ecology at the University of Kansas when we met there, and she became a lifelong recycler. So she will go through the house and sort the trash and make sure the recyclables go out in an appropriate way. Those lifetime committed people, I'm sure some of you are like this, are actually doing their part for reducing the waste stream. However, this is one of those things like smoking. Although we know the bad effects of smoking, after an initial drop in smoking, it then increased and dropped again. So it's been holding steady despite the known negative health effects. The same thing with recycling. We have laws that mandate the separation of recyclable materials and the pickup of curbside recycling. Our neighborhood has such a dual pickup. Actually, it has 3 pickups. It has a trash pickup, a recycling pickup, and a yard waste pickup every month. And we have checked, and they are going to appropriate composting or recycling facilities. However, it's not a universally accepted or employed method, so the effects of recycling on the waste stream could be much greater. Recycling also, by reducing the waste stream, gives us a bit of a break on the total amount of actual trash or toxic material we have to process. Japan recycles about half of all of its waste. It also takes pressure off of raw resources, although I would mention that Japan is a particularly interesting study. They buy things like mature logs for lumber and for wood fiber industries. They buy them from us, and they save their own forests. So they have a kind of an interesting perspective on Japanese resources and Japanese systems. We do, however, have behind everything an economic driver. The economic driver that I'm talking about is the concept of free enterprise. Everyone is free to pursue those activities that support their own personal gain. Is a part of the American way of life and Constitution. We do not look down on anyone simply because they pursue their own interests. And in terms of economics, we favor a policy of capitalism, so that money will drive the process. A business, its sole bottom line is whether it makes a profit. More profit is better, and less profit is worse. So behind that, we find economics. So we set up a system where we give the trees away when someone will go in and harvest them, a lumbering concern. So we basically pay more in the Pacific Northwest for maintaining logging roads, which was part of the government's responsibility, than we get from the leases of the companies that are harvesting those trees. So under those kinds of circumstances, it's much cheaper to get new raw materials, to dig new ore out of the ground, to take trees out of forests. And because of that economic difference, we continue to use new resources. It often makes the production of things like anything from can to furniture to whatever, it makes it much cleaner and more direct. It creates jobs, it stimulates the economy, get everybody busy and everybody working. So the increased cost of really truly efficient recycling is lost. Now, this is just a point of view, and that point of view is based on the idea that logs on national forests, those are free. If I can take them, I should get them. Grazing rights for national grasslands, those should be free. If I want to turn my cattle out there, I should get the grass for free, and so forth. Mineral rights and mineral resources like oil or mining for heavy minerals, those have always been given away for free, not for the market value. The value of the materials has always gone to the harvester, not to the government. This is just a point of view. And as a result, reasonable responses like recycling that we see here are only implemented to a partial extent, only to the extent where you can convince people of like mind to do it just for the esoteric and moral gains that you receive. So we see here percent recycled. Auto batteries were doing really well because they are nasty. But steel cans, yard trimming, paper and cardboard, all high proportions of recycling. All right, so this is where I stop for today. Stop that recording.